Hello, here are the notes for section 6.3, tests for parallelograms. This section actually is very similar to section 6.2, save for a couple of little weird things and the idea of basically what we're doing. So we're still working on proving theorems about parallelograms, and then in class, we're not going to do this in the video because it would take too much time, but we're going to use coordinates to prove simple geometric theorems algebraically, mostly prove that we have parallelograms. So that's basically the whole thrust of this section. Prove that you have a shape that's a quadrilateral, if it's a parallelogram or not. So we've recognized and applied properties of parallelograms. Now we'll ensure that a quadrilateral is a parallelogram and then use a set of points, from a plane to prove that we have a parallelogram again. So first of all, we have basically a bunch of ways to prove you have a parallelogram. The first way is the same way, kind of the first theorem about parallelograms. If you can prove that both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay. Another way, if you can prove that both pairs of opposite angles are congruent for a quadrilateral, then you have a parallelogram. Okay. The next way is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if you can prove that the diagonals have been bisected, which is one of our properties of parallelograms, you can prove you have a parallelogram. And then the fourth way here is if you can prove, and this is the kind of one weird way because it's the only thing that's not the same from section 6.2. But if you can prove that you have a pair of sides that are both congruent and parallel, so that's the one pair of sides, they're congruent to each other and they're parallel to each other, that'll give you a parallelogram as well. It forces the other two sides to be parallel and congruent too. So here are the 5 ways to do it. Okay, 5 ways to prove that you have a parallelogram. One is by using the definition. Okay. So by definition, if you can show that both pairs of opposite sides are parallel, you have a parallelogram. Now, we can actually do that with coordinate planes as well. We can do that if we use the slope formula. Okay. So that's one of the things we've talked about is if you have parallel sides, well, you can prove that by using the slope formula. If you want to show that both pair of opposite sides are congruent, okay, that's the other way. That's theorem 6.9. You can do that by using the distance formula as well. Distance formula. So when we do stuff in class tomorrow with this, one of the things how can I prove these sides are congruent? Well, I can either use, something that we've done before, or I can use the distance formula. Now, proving that both pairs of opposite angles are congruent, that one's the toughest because you really can only do that in a proof. You can't do that any other way. So if you're going to prove that both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent, it's full on in a 2-column proof. You're not going to prove that you have a pair of parallel congruent angles using the distance formula, the midpoint formula. I just want to even that up because it's kind of driving me nuts how sloppy that was. Yeah. There we go. Next one, show that the diagonals bisect each other. And that one's a little trickier. You can either have that they're congruent to begin with, or, oh, that's bad. Come on, you can do better than that. There we go. Yeah. Show that the diagonals bisect each other. Again, you can show that the parts are congruent, or if you want to do it with one of the formulas we have, we can also do that with the midpoint formula. So I'm going to actually put this down in an arrow down here. Just go straight arrow down. Okay. Midpoint formula. Because if you can show the segments that the diagonals of the same midpoint, then they bisect each other. Okay. So for that one, you'll see us using the midpoint formula. Ugh, this is all over the place. Should have thought this out a little better. Too late now. And then the last one, prove that the sides are both parallel and congruent. Well, if I'm going to prove and it's one pair of sides, parallel, I'm going to use the slope formula. And congruent, I'm going to use the distance formula. Okay, so some of the stuff we'll do in class, some of it will be here in the video. But those are our 5 ways to prove we have a parallelogram. Prove both pairs of opposite sides are parallel. That's by definition. If you need to do it with points, you do it with the slope formula. Show both pairs of opposite sides are congruent. That's theorem 6.9. We'd use the distance formula for that. Show that both pairs of opposite angles are congruent. That's theorem 6.10. That we just have to either have or we don't. Next, show that the diagonals bisect each other. That is theorem 6.11 midpoint formula. And then show that a pair of opposite sides is both parallel and congruent. Okay. So here's what I've got here. I've got 6 examples real quick. We're gonna kind of go through them. They'll pop up on the video, and then you'll tell me what you think if they're parallel, if it's a parallelogram or not. So here we go. First one. Okay, so hopefully for this one you said yes, and your reasoning was theorem 6.12. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. And we have a pair of sides that's both parallel and congruent. Next one. Okay, this one here, hopefully you said yes, this is a parallelogram, because you can see the diagonals, they're both cutting each other in half, which means this point right here is the midpoint for both diagonals. That's a point they have in common and they share. So hopefully you said yes for this one. Okay, so hopefully for this one here, you also said yes. This one's maybe one of the easier ones because you go back and you say, yeah, both pairs, come on, both pairs of opposite sides are congruent, so it has to be a parallelogram. Theorem 6.9. Okay, so this one here might seem a little tricky. You see a pair of congruent sides, 12 and 12, and you see a pair of parallel sides. However, it's not the same pair of sides. It has to be the same pair of sides in order for it to be a parallelogram that are parallel and congruent, and it's not, so actually this is not a parallelogram. This one here is also a little tricky. What you've got to recognize is that you have a pair of alternate interior angles, so this pair of sides here, these guys are parallel. Okay. You got another pair of alternate interior angles here, so these guys are parallel. So this is actually a parallelogram by the fact that we have the definition of parallelogram, because we have both pairs of opposite sides parallel. And then our last one here, this one, you can say it a few different ways, but probably the easiest way to do this is to realize, hey, I know there are 360 degrees in this figure, since it's a quadrilateral, and I've got 120 plus 60 plus 120 total, which is 360 minus 300, which then gets us 60 degrees left over. So this missing angle here, right here, is 60 degrees. So if that's 60, well, it's pretty obvious. No, I'm sorry, how did I get 60 out of that? That's 200. Wait, no. 240. No, Mr. Moyer. Gosh dang it. Oh, you're going to get angry at yourself here in the video. 60 plus 60 plus 120 is not 300. I was thinking I had two 120 degree angles. I had two 60 degree angles. Sorry about that. Wasted your time. That's 220. No, 240. Which then gives us 120 left over. There we go. Man, oh man, oh man. I could edit this out probably, but it'd be too much work. So just know that I'm not infallible. So 120 degrees for this one here. So now if both pairs of opposite angles are congruent, there we go. It's a parallelogram. So all of them were parallelograms except for the fourth one down here. Whenever we had the pair of sides that looked congruent but weren't, and looked, or one side was a pair that was congruent, one side that were parallel. That's not necessarily a parallelogram. In fact, next or later on in the chapter we'll call it an isosceles trapezoid. So, yeah. Now, for homework, okay, you've got 7 through 11 here. and what's happening is they're giving you a piece of information, one piece of information. You've got to figure out what piece of information that would you have to have as well as this to show that you've got a parallelogram. So there are actually kind of multiple answers to this. So it'll be kind of interesting to class together to see what you have for your answers. So yeah, hopefully that was an easy video, and if you have any questions at all, please come in and I'll be glad to help you out.